Hey everyone, and welcome back for another deep dive. Today we are going to be talking about metformin.
Metformin.
Which you probably know as a diabetes medication.
Uh-huh.
But we are going to be talking about all the other things it can do.
Yeah, it's way more than just diabetes.
So how did we even figure out that metformin had all this potential?
Well,
It's been around for a while, right?
it has. It's been around for over 100 years.
Wow.
Yeah, it was actually first synthesized in 1922.
Wow.
And so back then they were looking at it for malaria.
Oh, really?
Yeah.
Interesting.
And then they found that it could lower blood sugar.
Okay.
So by the late 1950s, it was actually being used to treat diabetes.
Okay, so this is a well-established
Yeah.
diabetes medication.
Exactly.
But it sounds like they didn't stop there.
No, they didn't. And that's what's so fascinating about it.
Okay.
Like, even after it became, like, the go-to drug for type 2 diabetes, they just kept digging deeper.
Yeah.
And they found all these other mechanisms of action.
So it wasn't just, okay, we found a use, let's move on.
Right.
They're like, no, there's more to the story.
Exactly. And it
Yeah.
turns out there's a whole lot more to this story.
Okay, so tell me about these mechanisms.
Yeah.
Like when people think of metformin, they think of diabetes, they think of insulin.
Right.
Do they think that it's making their pancreas produce more insulin? Is that how it works?
That's a really common misconception.
Okay.
Metformin doesn't really force the pancreas to make more insulin.
Okay.
What it does is it actually targets the insulin,
Okay.
which is like the underlying problem in type 2 diabetes.
So it's helping your body better use the insulin it's already making.
Exactly.
Gotcha.
And one of the really cool things is that it doesn't by itself cause low blood sugar,
Oh, okay.
which can be a dangerous side effect of some diabetes.
Right,
So
right.
it's a much safer option in that regard.
So it's kind of helping your body work smarter, not harder
Right.
when it comes to insulin.
I like that.
Okay, so that's how it works for diabetes. But you said there's a lot more to it.
There is.
So what else is going on?
Well, one of the key things that metformin does is it affects these things called mitochondria.
Mitochondria.
Yeah,
The powerhouses of the cell.
exactly. The tiny powerhouses inside our cells.
Okay.
And specifically, it acts on something called complex I
Complex.
in the mitochondrial respiratory chain.
Okay, I'm going to need you to break that down for me a little bit.
Sure. So think of the mitochondria as the energy factories of our cells.
Okay.
And complex I is like a crucial part of the machinery that's generating that energy.
Okay.
And what metformin does is it basically tweaks how this machinery works.
Okay.
And that leads to this whole cascade of downstream effects.
So it's not just throwing more fuel on the fire.
Right.
It's like fine-tuning the engine itself.
Exactly. It's like a tune-up for your cells.
Okay. Like,
And these adjustments, they impact how cells utilize glucose, fat,
okay.
how they respond to stress.
Okay.
And there's even some evidence that it might influence aging processes.
Wow. So we're talking about like influencing how our cells function at their very core.
We are.
That's incredible.
And there's another really important player in this whole metformin story,
Okay.
and that is AMPK.
AMPK.
Yes, AMPK, which stands for AMP-activated protein kinase.
Okay. Another acronym.
Another acronym I know.
But I'm guessing this one's important.
AMPK is essentially like the cell's energy sensor.
Okay.
So when energy levels in a cell start to dip,
Okay.
AMPK gets activated.
All right.
And it basically tells the cell, hey, we need to conserve energy. Let's ramp up our efficiency.
Okay.
And guess what?
What?
Metformin is a really potent activator of AMPK.
So it's basically sending this signal to our cells saying, hey, let's get our energy management in check.
Exactly.
Right.
And that signal through AMPK, it influences a whole bunch of processes.
Okay.
Things like glucose uptake,
Mm-hmm.
fat metabolism, even how cells deal with stress.
Wow. So we're seeing that metformin is working on multiple levels here.
It is.
It's not just a single target.
It's a multitasker.
Okay.
And just when you think it couldn't get any more,
Yeah.
we find this really surprising connection between metformin and our gut microbiota.
Hold on. Wait a minute. Our gut bacteria?
Yes, your gut bacteria.
What does that have to do with anything?
Well, it turns out that metformin can actually change the composition of our gut bacteria.
Oh, wow.
It can promote the growth of beneficial bacteria
Yeah.
while reducing harmful.
Okay.
And we're learning more and more these days about how important a healthy gut is for all.
The gut microbiome is so important for so many.
It really is. So in a way, you could say that metformin is kind of like a gardener for your gut,
Oh, I like that.
helping to cultivate a flourishing ecosystem.
Okay, so it's affecting the gut bacteria, but is there more to that connection?
There's even more to it.
Okay.
Metformin also stimulates the release of something called GLP-1 from our gut.
GLP-1. Okay, can you remind me what GLP-1 is again?
So GLP-1 is a hormone that helps regulate both insulin secretion
Okay.
and appetite.
So by boosting GLP-1, metformin's indirectly helping to control blood sugar, and it could even be influencing how full we feel.
Exactly. It's hitting those targets from multiple angles.
It seems like this one drug is conducting a whole symphony of positive changes throughout the body.
I know, it's pretty remarkable, right?
Yeah.
And there's one more piece to this puzzle we need to talk about.
Oh, okay.
And that is GDF-15.
GDF-15. All right, lay it on me. What's GDF?
So GDF15 stands for Growth Differentiation Factor 15.
Okay.
And it's basically a signaling molecule that metformin increases the release of.
Okay.
And GDF15 plays a role in appetite regulation and weight,
Got it.
which might explain why metformin is often linked to modest weight.
That makes
So we've got metformin interacting with mitochondria,
Mm-hmm.
activating AMK,
Hmm.
shifting gut bacteria, increasing GLP-1, and now this GDF15.
It's a lot to take in, but it's just incredible how one drug can have such widespread effect.
It really is, and we've only just scratched the surface here.
Oh, wow.
Next, we're going to delve into some of the most intriguing areas of metformin research, where scientists are exploring its potential far beyond.
All right, I am ready. Bring it on.
Okay,
Let's do it.
let's do it. So I'm sure you're wondering what those other benefits.
Yeah, like what else can this thing do?
Well, one area that's getting a lot of attention is cardiovascular.
Okay, so we know that diabetes increases the risk of heart, but metformin is doing something more than just controlling blood sugar to protect the heart.
Yeah, that's what research suggests.
Okay.
Studies have shown that metformin can actually improve what's called endothelial function.
Endothelial function. Remind me what that is.
Okay, so basically the endothelium is the lining of our blood vessels.
Oh, okay.
It's this thin layer of cells, but it plays a really important role in regulating blood flow,
Okay.
blood pressure,
Okay.
even blood clots.
So if your endothelium is healthy, then your blood vessels can dilate and constrict
Exactly.
to keep the blood flowing smoothly.
Exactly. And when it's not functioning properly, that's when you start to see problems like high blood pressure and an increased risk of heart attack, stroke.
So metformin is helping to keep the blood vessels nice and flexible,
Right.
which takes the strain off the heart.
Exactly. And the
Uh-huh.
potential benefits don't stop there.
Oh, there's more.
There's more.
Okay.
There's even some really interesting evidence that metformin might play a role in fighting cancer.
Oh, hold on. Metformin and cancer. Okay. I need to hear more about this.
Yeah, so it actually started with epidemiological studies.
Okay.
Where researchers noticed that diabetic patients who were taking metformin seemed to have a lower risk of developing certain types of cancer
Okay.
compared to those who were taking other diabetes medications.
So it's not like metformin is a cure for cancer,
Right.
but it's somehow influencing cancer development.
Yeah, it's raising some really interesting questions.
So how could a diabetes drug possibly have an effect on cancer?
Well, there are a couple of potential mechanisms at play. One has to do with its effect on insulin and IGF-1 signal.
Okay.
Now, high levels of insulin and IGF-1,
Which is?
a growth factor,
Okay.
have been linked to an increased risk of cancer.
Okay.
So by improving insulin sensitivity and lowering insulin levels, metformin could be indirectly reducing that risk.
Okay, so it's restoring that balance in the hormonal system.
Exactly.
Okay.
Another really interesting angle is metformin's impact on cellular energy metabolism.
Okay.
Remember how we were talking about its effect on mitochondria?
Yeah.
Well, cancer cells have this really strange way of generating energy.
Okay.
They rely heavily on a process called glycolysis,
Okay.
even when oxygen is available.
It's not the most efficient way to do it.
No, it's not. It's pretty inefficient.
Okay.
But it's a hallmark of cancer cells.
Yeah, they've got their own weird way of fueling themselves.
They do.
Okay.
And what's really interesting is that metformin, by tweaking those cellular energy pathways, might be able to interfere with that abnormal energy metabolism
Okay.
in cancer cells
Okay.
and potentially slow down their growth.
Whoa, so it's like a double whammy.
Kind of, yeah.
It's affecting the hormones and it's messing with cancer's fuel supply.
It is.
That is incredible.
It's really fascinating how this one molecule can have such a ripple effect throughout the body.
Yeah, it really shows how everything's connected.
Exactly.
Okay, so we've talked about the heart, we've talked about cancer. What else?
All right, let's shift gears a little bit and talk about metformin's potential in protecting our brains.
Okay, now we're talking neuroprotection.
Right.
This is another area where metformin could have a huge impact.
It could. So there's emerging research looking into whether metformin might help protect against neurodegenerative diseases like Alzheimer's.
So we're talking about possibly preventing or slowing down cognitive decline.
Exactly.
Okay, that would be huge.
It would be a game changer.
So how does it do that?
Well, the research is still pretty early, but the initial findings are promising.
Metformin's ability to reduce oxidative stress and inflammation,
Along with its effects on those cellular energy pathways we were talking about earlier,
Right.
might offer some protection against the damage that accumulates in brain cells over time.
So it's like giving brain cells extra armor
Yeah, I like that.
to help them withstand all that wear and tear that can lead to cognitive.
Exactly.
Okay, cool.
And now, are you ready for the most intriguing aspect of metformin research?
Lay it on.
Okay, we're talking about metformin's potential role in actually slowing down the aging process.
Wait a minute. Are we talking about a fountain of youth pill here?
Let's not get ahead of ourselves.
Okay.
But metformin is definitely one of the leading candidates in the field of aging research.
Okay.
It's showing a lot of promise in influencing what are known as the hallmarks of aging.
Okay, break that down for me. What are the hallmarks of it?
So these are basically the processes that contribute to the decline we experience as we get older.
Okay.
Things like
The accumulation of damage in our cells, changes in our metabolism, the shortening of our telomeres.
telomeres, those are the caps on the ends of our chromosomes, right?
Exactly. They're like the protective caps.
Okay.
And they get shorter as we age.
Okay. And so metformin is affecting these hallmarks.
Yeah, it seems to be having an impact on several of them.
Okay.
We've already touched on a few, like its effects on mitochondrial function, inflammation, and cellular energy balance.
Okay.
But there's also growing evidence that it might be influencing things like cellular senescence.
Cellular senescence. Okay.
Yeah.
I don't know what. Explain it.
Sure. So basically imagine our cells have a lifespan.
Okay.
As they get older, they can enter this state called senescence,
Okay.
where they stop dividing, but they don't die off like they should.
Oh, so they're just kind of hanging around?
They're hanging around.
Okay.
And they can actually release harmful substances that contribute to age-related decline.
So they're like zombie cells.
Yeah. Zombie cells. Yeah, that's a great way to put it.
They're not doing their job anymore,
Nope.
but they're still there.
They're still there causing trouble.
Wow.
And what's really interesting is that metformin seems to be able to modulate this process of cellular senescence, potentially reducing the number of these zombie cells
Okay.
and the damage they cause.
So it's like hitting the pause button on the aging clock at a cellular level.
It's a possibility that researchers are really excited about.
Okay, so how do we know if this is really working in human?
Well, there's actually a clinical trial underway
Okay.
called the TAME study.
Cavey.
Yeah, it stands for Targeting Aging with Metformin.
Okay.
And they're directly assessing whether metformin can delay age-related diseases and extend lifespan in humans.
Wow. Okay, so the TAME study, that's one to keep an eye on.
Definitely.
So this is all incredibly exciting stuff. But I have to ask, is there a catch?
That's a good question.
Like, it seems almost too good to be true.
Yeah, and it's important to temper our enthusiasm with a healthy dose of caution. The research on metformin's broader benefits is really promising, but a lot of it is still in its early stages.
So we're not all going to start popping metformin and live to 200.
Probably not.
Okay, good to know.
Yeah, a lot of the studies we've been talking about are what are called preclinical studies,
Okay.
which means they've been done in cells or in animals.
So not in humans yet.
Not in humans yet, and while those findings are really valuable,
Yeah.
we need more robust clinical trials in humans to really confirm these benefits,
Okay.
determine the optimal doses,
Right.
and assess the long-term safety.
Okay, so science takes time.
It does.
We got to be patient.
We do. And
Yeah.
there are a few other things to keep in mind, too.
Okay.
For example, some of the effects that they've seen in lab studies
Yeah.
use much higher doses of metformin than
Right.
what's typically prescribed for diabetes.
So we can't just assume that taking a bunch of metformin is going to turn us into superheroes.
Right. We need to follow the science and wait for the evidence from well-designed clinical trials.
Right.
It's also really important to be aware of the potential downsides.
Okay, what downsides are we talking?
Well, metformin is generally considered pretty safe,
Okay.
especially at the doses used for diabetes.
Okay.
But it can cause some gastrointestinal side effects,
Okay, like what?
things like nausea and diarrhea,
Oh, yeah, okay.
especially when you first start.
Okay, but those are usually temporary
Usually, yeah.
and manageable.
Exactly. And starting with a low dose and gradually can often minimize those side effects.
Okay.
A more serious but much rarer concern is something called lactic acid.
Lactic acidosis.
Yeah.
Okay, what's that?
So that's a buildup of lactic acid in the blood.
Okay.
And it's a serious condition.
Okay.
But it's very rare, and it usually only happens in people who have health problems,
Okay.
like kidney or liver issues.
So again, it's really important to talk to your doctor
Absolutely.
before starting metformin. Make sure it's right for you.
Yes.
And one other thing I was thinking about,
Mm-hmm.
we've been talking about the effects of metformin on individuals,
Yeah.
but what about the impact on the environment?
That's a really important consideration.
Like, we're hearing more and more about pharmaceuticals
Mhm.
ending up in our waterways.
Right.
Is that a concern with metformin?
It could be.
Okay.
Metformin doesn't break down easily in the environment.
Okay.
And so with millions of people taking it every day, some of it's inevitably going to end up in wastewater.
Okay, so what does that mean for the environment?
Well, it's an area of active research.
Okay.
Scientists are still trying to figure out the long-term effects of metformin in our ecosystem.
Okay.
But some studies suggest that it could potentially act as an endocrine disruptor in aquatic life.
Endocrine disruptors. Those are chemicals that can interfere with hormones.
Exactly.
Okay.
And hormonal disruption can have all sorts of negative effects on animals, things like reproductive problems, developmental abnormalities.
So it's not just about human health. We have to think about the planet too.
Exactly. As with any widely widely used medication. We have to carefully weigh the potential benefits against the potential risks for both ourselves and the environment.
That is a great point to keep in mind.
It is.
Okay, so we've covered so much today.
Yeah.
Metformin is such a fascinating drug.
It is.
With so much potential. I'm excited to hear your final thoughts on it as we wrap up this deep dive.
Yeah.
Okay, so we've covered a lot of ground today with metformin.
We have.
I mean, from its history as a diabetes drug to its potential for maybe treating heart disease, cancer, even influencing the aging process.
Right.
It's kind of mind-blowing to think that one little pill could have such wide-ranging effects.
It really is.
Like, how is that even possible?
Well, it really speaks to the fact that our biological systems are so interconnected.
Okay.
And, we're still really just beginning to understand the complexities of human health.
Yeah, and metformin's like a perfect example of that, right?
It is.
It's like we keep peeling back layers of the onion, and with each layer, we're like, whoa, there's even more to this.
Exactly. And who knows what other secrets this little pill holds.
Right. So, like, what's next for metformin research?
Well, researchers all over the world are continuing to study it.
Okay.
They're looking at its potential in a whole range of conditions.
Wow, wow.
From, things like polycystic ovary syndrome to fatty liver disease.
Okay.
Even some rare genetic disorders.
So it sounds like the future of metformin research is pretty bright.
It is. It's a very exciting time to be following this field.
Yeah, and it's exciting to think about how it could potentially help so many people.
Absolutely.
But like with any medical treatment, we have to be realistic, right?
Of course.
There's no magic bullet for everything.
Exactly. And it's not about self-medicating or jumping on the latest health trend.
Right.
It's really important to make informed decisions and to consult with your healthcare professional.
Absolutely.
Yeah.
Because they can help you weigh the potential benefits and risks.
Exactly. They can take into account your individual medical history, your lifestyle factors, and help you decide if metformin is right for you.
Okay, so as we wrap up this deep dive into metformin, what's the one key takeaway you want our listeners to remember?
I think the biggest takeaway is that metformin is a really powerful reminder that scientific discovery is a continuous journey. Okay. It's about constantly questioning and exploring and pushing the boundaries of what we know.
It's about being curious and staying open to new possibilities.
Exactly, even in something as seemingly simple as a common medic.
Yeah, because you never know what you might find.
Right, there's always more to learn, and the more we learn, the more we realize how much we don't know.
Well said. That is a great note to end on. Thanks so much for joining us on this deep dive into metformin.
My pleasure.
We hope you found it informative and maybe even a little bit inspiring.
I hope so too.
And until next time, keep asking questions, stay curious, keep diving deep.